Staying awake past your body's natural wind-down window isn't just making you tired tomorrow. It may be quietly sidelining one of your immune system's most important frontline defenders. Deep inside your immune system, a specialized cell type called a natural killer cell is responsible for patrolling your body and hunting down cells that have mutated or been hijacked by a virus. And there's growing evidence that when your sleep timing is consistently out of sync with your circadian rhythm, these cells don't perform at their best. Tonight, we're breaking down the biochemical relationship between your sleep timing, your melatonin release, and your immune system's internal security team, and what the science actually says about protecting it. The genetic security breach. Why this is about more than just feeling tired. Everyone knows that missing sleep makes you groggy the next day. Fewer people know that your sleep timing, not just the total hours you get, is tied to a nightly process your immune system depends on. Your body runs on a roughly 24-hour internal clock called the circadian rhythm, which doesn't just control when you feel sleepy. It also governs hormone release, body temperature, and critically, the activity level of different immune cells throughout the day and night. Immune function isn't static. It has its own daily rhythm, and disrupting your sleep-wake cycle can disrupt that rhythm along with it. Meet your natural killer cells. Natural killer cells, or NK cells, are a type of white blood cell that's part of your innate immune system, the branch of immunity that responds quickly and generally, rather than needing to learn a specific threat first. Their job is distinctive. Rather than waiting for a specific trigger like an antibody, NK cells constantly scan the surface of your own cells, looking for ones that look abnormal, cells infected by a virus, or cells that have started dividing in a mutated, potentially cancerous way. When they find one, they can destroy it directly. This is why researchers often describe NK cells as an internal surveillance system, hunting for threats that have already gotten inside rather than waiting at the border. The circadian connection. Here's where sleep timing enters the picture. NK cell activity has been shown in sleep research to follow a daily rhythm, and disrupted or shortened sleep, particularly sleep that's misaligned with your natural circadian signals, has been associated in multiple studies with reduced NK cell activity the following day. One well-cited area of research comes from studies on partial sleep deprivation, where participants who slept significantly less than usual showed measurably lower NK cell activity compared to when they were well rested. The takeaway isn't about one specific clock number being magic. It's that consistent, circadian-aligned sleep appears to be a meaningful input into how well this part of your immune system performs. The melatonin connection. What melatonin actually does. Melatonin is often called the sleep hormone, but that undersells its role. It's produced by the pineal gland in response to darkness, and its release typically begins ramping up in the evening. For most adults, somewhere in the 2 to 3 hours before their usual bedtime, as part of the signal that tells your body it's time to wind down. Beyond sleep regulation, melatonin has documented antioxidant and immune-modulating properties. Some research suggests it interacts directly with immune cells, including NK cells, potentially supporting their activity as part of your body's overnight repair and defense processes. Why 11 p.m. is a useful guideline, not a universal law. This brings up an important nuance. You'll often see 11 p.m. cited as a magic bedtime cutoff for immune health. It's a reasonable, practical guideline for a lot of adults because it approximates when melatonin naturally begins rising for a typical sleep-wake schedule. But it isn't a universal biological deadline etched into every person's biology. Your actual optimal window depends on your individual chronotype, whether you're naturally more of an early riser or a night owl, and your typical wake time. The real principle behind the 11 p.m. rule isn't the specific number on the clock. It's consistency and alignment with your body's natural melatonin rise, whenever that happens to occur for you. Someone who wakes at 5 a.m. will have a different ideal window than someone who wakes at 8 a.m. The blue light disruption. One of the most well-established disruptors of this process is light exposure at night, specifically blue wavelength light, the kind emitted heavily by phones, tablets, and many overhead LED lights. Blue light exposure in the evening has been shown in research to suppress melatonin release and delay its natural rise, effectively pushing back your body's internal signal that it's time to wind down. Some studies looking at nighttime screen use have found measurable reductions in subsequent immune markers, including NK cell activity. Though the exact magnitude varies across studies and populations, this remains an active area of research rather than a single settled number. What's consistent across the research is the direction of the effect. More late-night blue light exposure is associated with delayed melatonin release, and delayed melatonin release is associated with worse sleep quality and reduced next-day immune markers. What happens when you miss the window repeatedly? The short-term effect, one bad night. Missing your ideal sleep window once isn't catastrophic. Your body is resilient, and a single night of delayed sleep or shortened rest typically causes a temporary dip in NK cell activity and general immune readiness, the kind of thing that corrects itself once you catch up on rest. The concern researchers focus on is the cumulative effect of chronic misalignment, not the occasional late night, but a consistent pattern of going to bed well past your body's natural wind down signal, night after night, week after week. The long-term effect, chronic circadian disruption. Populations that experience chronic circadian disruption, most notably shift workers who regularly work through the night, have been studied extensively, and the research consistently shows associations with altered immune function, including changes in NK cell activity, along with broader health risks linked to long-term circadian misalignment. This doesn't mean occasional late nights are dangerous. It means that a body clock that's consistently fighting against its natural rhythm, rather than working with it, has less opportunity to run the nightly repair and immune surveillance processes that appear to depend on that rhythm being intact. Why this matters for silent cellular threats. Part of what makes NK cell surveillance important is that it's designed to catch problems before they become noticeable. Cells that have mutated, or cells harboring a virus that hasn't yet caused obvious symptoms. This is sometimes described as silent surveillance because you don't feel your NK cells working, the same way you don't feel your liver filtering your blood. That's exactly why circadian-aligned sleep is worth taking seriously even when you feel fine. The value of a well-functioning surveillance system isn't something you notice on a normal day. It's something that matters most on the days you don't yet know you need it. How to actually protect this system. Here's what the research actually supports as practical steps. Not a rigid 11 p.m. law, but principles that support the biology behind it. Step 1. Find your actual wind-down window. Instead of fixating on 11 p.m. specifically, work backward from your ideal wake time and count back 7 to 9 hours. Then build in a wind-down period before that. If you wake at 6:30 a.m., your target bedtime is likely closer to 10 or 10:30 p.m. If you wake at 8 a.m., it may genuinely be closer to 11:30 p.m. or midnight. Consistency night to night matters more than hitting any single specific hour. Step 2. Reduce blue light exposure in the 2 hours before bed. Since blue light is one of the most well-documented disruptors of melatonin release, dimming overhead lights and switching devices to night mode, or better, putting them away entirely, in the couple of hours before your target bedtime gives your body's natural melatonin rise a chance to happen on schedule, rather than fighting against artificial light signals telling it to stay alert. Step 3. Keep your schedule consistent, including weekends. One of the most common disruptors to circadian rhythm isn't a single late night. It's an inconsistent schedule, where bedtime and wake time shift by 2 or 3 hours between weekdays and weekends. This pattern is sometimes referred to as social jet lag, and it can create a chronic, low-grade version of the same misalignment seen in shift workers, just less severe. Keeping your sleep-wake schedule consistent, even on days off, gives your circadian rhythm, and the immune processes tied to it, a stable signal to work with. Step 4. Support the process, don't force it. You can't will your NK cells into higher activity through sheer effort, but you can create the conditions that support the process. A consistent wind-down routine, a dark sleeping environment, and alignment between your bedtime and your body's natural melatonin rise. Over time, these are the levers research consistently points back to. Not a single magic hour, but a stable, circadian-respecting rhythm night after night. Your immune system isn't only working while you're awake and moving through your day. A significant part of its surveillance and repair work is tied to what happens while you're asleep, and specifically, to whether that sleep is aligned with your body's natural rhythm. The 11 p.m. rule, isn't a strict biological deadline that applies identically to everyone. It's shorthand for a real, evidence-supported principle. Consistent, circadian-aligned sleep appears to give your natural killer cells and your immune system more broadly the conditions they need to do their job well. If tonight's video changed how you think about your bedtime, share it with someone who treats sleep as optional. Subscribe for more evidence-based breakdowns of the science behind your everyday habits, and let us know in the comments. What time does your body actually start winding down?